Hello and welcome to lecture 2 on Objective-C. We are moving on to a little bit more about object-oriented programming in Objective-C, how things are different and how things are the same. We are going to build on top of the same example we had in the last lecture, and then in the end of this lecture we will create a simple Mac OS, an OS 10 application, but an actual graphical application. So we're going to jump ahead of ourselves and see what's actually coming. Okay, one of the questions I got after the last lab is there another way to create objects? And some people were just confused about creating objects. So here it is. There are two ways of properly creating objects in Objective-C. And first way I showed you before, it's calling an allocation routine on the class, which will create the space in the memory, allocate that space, and put the actual instance in there, and then call the init method on the object, which will make the object usable. This is a good way, it's proper. But there's another way of doing almost the same. It's right here, and all we're doing here is we are calling the string method on the NSString class. And you have to check with the classes, but the common naming convention is you use the name of that class in some way. So here we have a string method because it's a string, but the class itself is NSString, so it kind of makes sense. So the string method will do the same. It will allocate the memory, then it will call the init method on that object, which it just allocated space for, and will return this object ready to use. The difference is the second way, this way, is more automatic. First of all, well, you don't have to do it manually. You don't have to allocate and then initialize. But the most important thing is you don't have to worry about memory. You don't have to worry about releasing the memory after you use it. But the truth is you don't have to worry about memory in the first case neither. Now, why do we have it? Well, it's not that long ago we didn't have that ability. We didn't have that feature of not worrying about memory. We needed to worry about memory because there was no way of releasing the memory automatically unless you use this special way of creating objects. You might remember in the last lecture or in the lab where you creating your first project in Xcode, the window where you type the name of the project and choose the frameworks, there was a simple, small checkbox, and that checkbox said use automatic reference counting. And by default, that checkbox is on, and I hope you didn't touch it because that allows you not to worry about memory. We're going to see a bit more about memory in this lecture, but we're going to have a big lecture just on memory management and why is it important in the following weeks. For now, consider those two ways the same, because today we have this modern Objective-C and we have modern Xcode, and we don't have to worry about releasing the memory. Another thing to consider if you use the first way is some classes provide you with more complex ways of initializing. So in this case, we're creating a number. So we created a pointer, then we called an NSNumber class. We send it an alloc method, an alloc message, I'm sorry. This will return us an object in the memory, which we have to initialize. And what we can do here is NSNumber has this ability to respond to this particular command. Or in other words, it has a method called init with float, and it includes the init routine, so it actually does the same as this, but it also sets the value of your number to float, to 1. And NS number is a generic number, so it can be an integer, a double, a float, a long number, etc. In this case, we're saying it will be float, and I want it to be of this value. You can just check the documentation and see what all those built-in classes and NS next step classes have for you to use. And also it's a good idea to consider for classes you're creating yourselves. So if you're making a class which at some point other programmers or you will use and will initialize, you might override or write your own init method which will include the built-in init and then maybe take some parameters, assign some values. This is not a huge feature, this is not a revolution, but it just saves you some time and it can save you a line. Otherwise, you would do the same, you would do like this, init your number, and then on the next line, assign it a value of whatever you need. Okay. Another thing to consider as your history, which you don't really need to worry about, if you're programming for modern operating systems and using modern Objective-C and Xcode, is releasing objects. So if you didn't put that checkbox when you were creating your first project, the checkbox being use automatic reference counting. By the way, if you are seeing somewhere in the text on the internet or maybe in documentation, in messages in Xcode, an acronym ARC, that is automatic reference counting. So sometimes Xcode says ARC does not support this, and that means automatic reference counting. One of the things where you're going to see this is if you do put that checkbox, or you actually don't touch that checkbox because it's on by default, and then try to release the memory manually using this method, release. The Xcode will say we have an error because ARC does not support release. Because you don't have to worry about release. The Xcode will do it, the Objective-C will do it for you. But if you don't have ARC enabled, then you have to release the memory yourself. Let me tell you a story. In one of the interviews I had for a job, there was a question. What is the difference between C++ and Java? And I started saying, with the garbage collector. By the way, another good answer everybody's looking for is Java compiles into a bytecode which runs on Java virtual machine, and that's what makes Java cross-platform. You can create a Java program, compile it, and then run that bytecode on any platform, because you're not running it on the platform itself, you're running it on the Java virtual machine. And the top layer of that Java virtual machine that actually responds to your program is the same on all platforms. And what different is how that virtual machine works on the operating system. But you as a programmer don't have to worry about this. And what Java did, what Sun did, they just created this another layer of abstraction, kind of another operating system on top of your operating system, and made it the same on the surface so that all the programs written in any platform could run on it. And then its job is to make it possible to convert all those commands to the base operating system itself. This is why Java programs, in theory, run on Linux, on Windows, on Mac, etc. So that was a good answer, I hope. Another good answer they were looking for is garbage collecting. Unlike C++, Java does worry about memory for you. And if you are creating objects and arrays and whatnot, and at some point stop using it, Java will release that memory for you, so you don't have to worry about it. And that memory, which is not being used and not being accessed by anything, not even possible to access being accessed by anything, considered garbage because it just stays there, takes up the space, and it's not useful. This is why that thing in Java is called garbage collector. So I answered that question, they were happy, but the next question I did no answer for. And that question was, well, how that garbage collector works. How does it know what to delete and when to delete it, when to free memory? So I started guessing, and I don't quite remember exactly what I said, but I do remember I didn't know the correct answer. So I probably guessed some part of it. The answer was surprisingly simple, and I didn't know it was so simple. Again, this is just a huge simplification, but in a couple of words, all Java does is it counts how many times you are saying you're going to use this. So let's say you created an object in memory, just like this. You created a pointer, then allocated some memory for that. Then you're saying, I'm going to use this, and some function use this. All Java does is it increments a counter when someone says, I'm going to use it. And when that something stops, when that function terminates, it decrements the counter. So if I create an object and then 10 different routines are using this object, then the counter will be 10, because every time another routine says I'm going to use it, the counter goes up. So garbage collector just goes from time to time over all the memory and checks if there is an object that has a counter 0, meaning nobody uses it, and then it deletes it. This is oversimplification, and it's a bit more complicated than that, but idea is counting, just counting how many times you're using it, how many times you are referencing it. This is why it's called reference counter. And today we are enjoying this automatic reference counting in Objective-C. We used to have these commands, and you still might use it someday, release and auto-release. So release deletes this memory right away on the same line. So the next line you cannot use string2. If you say string2 auto-release, that will release the memory sometime in future, but not right away. You're not sure what time in future, but all you know is it will wait until the current function ends. So if you are writing a function and you know that you're not going to use this variable after this function ends, you might say auto-release and then still use string2 until the end of this function. It will be there. It won't be deleted. But again, consider this your history. For purposes of this course, we don't ever see release and auto-release as methods. Okay, so let's take a look at our example from the last lecture. We had that fraction class, which we used to create fraction numbers. And what we had is two variables, a numerator and denominator, which represented those two parts of the number. And to set those values, we had two functions which we created. And those functions are set numerator and set denominator. So they're simple. All they do is set the value to the parameter we pass. But this is kind of stupid, right? Why are we doing this? This is so simple, a computer can do it for us. So if you were programming in Java using Eclipse or NetBeans or some other modern complicated IDE, then there was probably a way to generate those getters and setters. It wasn't the part of the language, it was the part of your programming environment. This is just the tool that generates exactly the same code, but you don't have to write it because it's so simple and trivial. Computer knows how to do it. Objective-C actually gives you even better way, even a better tool. So instead of writing this code or generating this code, it will give you a way to avoid it, but actually generate getter and setter methods for you. So what we have to do first is to declare those variables that we want getters and setters be generated for. So in this case, we want those two variables to be generated, getters and setters. So instead of putting them here in implementation, we are going to go over to the interface and declare them as properties. So we have a keyword property, and Xcode again suggests that we use that word because we started typing it. And if I just say, if I click tab on my keyboard, you will complete it. And then all I have to say is the same thing. I have to say int numerator. Oops. Just passed it here. And the second one is integer 2, it's a denominator. So now we don't need this. We actually don't need the whole block because we don't have any more variables. So those two are properties now. This is why we don't need those two functions. We don't need to write them. So I delete it from the interface and I delete the implementation. What's left now is to say I want those getters and setters be generated. And another way of saying generated is synthesized. So this is why we have synthesize keyword in Objective-C. And here we just have to say what we want to be synthesized. So we have the numerator, again, autocomplete, and denominator, tab, and save. Nothing else has to be changed. We still have this set numerator and set denominator, but we didn't write those. They were generated by this synthesizer. So don't forget that since even though we had the numerator starting with a small number, small letter, we have a function generated with the big one here. And of course, we can access it by saying my fraction numerator and respectively denominator. So here's the slide, just to recap. First of all, declare properties you want as properties in the interface. And in the implementation, say synthesize and list all the variables you want to synthesize for. And you don't need to put them by type. So if you had a string and integer and maybe different types in the property, then you can just do the same and put them all in the single list. All you're saying is synthesize for the following properties. Okay, so this is more about style than the language, but this language is all about style. It's about styling the way you write code. And if you know by now, I hope you know how to create methods, then the first urge you have is the first thing many programmers do when they switch from C++ or Java to Objective-C is they using the same principles and they using the same ways. So we did it in the last lecture. We created my fraction. We created a fraction class and created two methods to set numerator and denominator. And this is exactly what you would do in C++ or Java, probably. The better way is combine those methods that are logically together. So numerator and denominator, they kind of the same type. So we should probably make it a single method. The good thing is we can, and the good thing, another good thing is we can do it nice. So just make another method which is a single method to set both numerator and denominator. You probably would do at some point the same in C++, and you would say set number and then pass two parameters, numerator and denominator. But this is still not Objective-C. I mean, this is Objective-C, this is the language, but this is not the style I'm trying all of us to get used to. All you're saying here is set numerator to something and set denominator to something, and this is okay. Probably you will do something and, because the key idea here is you want to read this as English, and you're kind of reading this as English, set numerator to 10 and denominator to 22. But again, this is not proper English. In English, you would say, set my fraction to 10 over 22. And this is the style I want you to use. I want you to write functions as if they are statements in English language. I want you to write them as close to the human language we're using. So a good thing here would be to say my fraction set to 10 over 22. And set to colon over colon will be the name of our argument. So let's add something to our class. Let's do that. But actually, I'll leave it. I will not waste the time on this because half the lecture is gone, and you got the idea. You just convert the functions you have into more readable functions, into more logical. Okay. Here's another thing, the self. If you remember Java, then you remember the keyword this in C++ or Java. And self is almost exactly the same. But the difference is this is the keyword in C++. That means it's not a variable. It's not something you can use as a variable. It's just a keyword. It is being replaced by something else, and it's there just to make it easier. Self in Objective-C is a variable. That means you can change the variable. You can change what self is. Now, the idea is exactly the same. Self is just a pointer to the current instance. Okay, to show you what that is about, I want to write another method here. And that method will be an add method. And it will take a fraction and add that fraction to the fraction we're using here. So all it does is takes a fraction and adds it to the fraction we have. So let's implement it. We have add and yes and yes. All I want to do here is I want to say numerator equals a numerator plus f numerator, and say for here that is actually really wrong. To add fractions, I need to multiply the numerator by f denominator and then add the f numerator, then by and like this. I'm starting to forget math. So this is just a method which will add a fraction to a fraction we have. And another thing I want to write is a reduce method, because if we having a fraction 10 over 2, that is not reduced fraction. We want to have 5 over 1 or 5. So I want to write a method called reduce, won't take any parameters, and will reduce the fraction we have. So I want to create local variables. Integer u will be our numerator, integer v will be our denominator, and we need a temporary integer. Now we have a while loop until v is not 0. I want to divide, get the residue. So all I'm doing is just finding a common smallest common denominator so that our thing could be reduced. Oops, forgot the equal sign. Numerator will be divided by u, and denominator divided by v. Okay, so that will convert our fraction to the actual reduced fraction, the smallest one. And why I did this is, when we're adding fractions, this is probably the good time to reduce the resulting fraction if we have a fraction that needs to be reduced. If I want to call the function, the method of the object I'm currently in, then we would say self and reduce. In C++, we would say this reduce, meaning what happens on this line is we are inside the object, and I want to call a method on this object where I'm in. I would say self reduce. We're not going to talk today about how this self variable could be changed, but sometimes it's good, it's usable if you want to change what self points to. But by default, it points to the current instance or the current object. Okay, I told you about inheritance last time, and that was a simple thing. Objective-C supports single inheritance only, no multiple inheritance. And there's basically nothing really new to you. It's the same idea from object-oriented programming. It's the same mechanism that you have in C++. Unlike C++, we don't have multiple inheritance, but that's mostly it. The way a method is being called is first place where the language looks for the method you're calling is the object itself, the class, the immediate class. And if it's not there, if it doesn't have this method, then it will look to the immediate parent. So the class that you inherited from when you created this class. And if it's not there, it will go on looking to all the parents. It will go on to the next parent, so to the kind of grandparent of your class, and then to the next one, until one of the two things happen. Until that method is found, then it's going to be called, or until the root class is reached, meaning you reach the class that doesn't inherit from anything. It's your greatest parent. And if method is not there, bad news, there is no this method at all. So there will be an exception or just an error. Okay, when we created the fraction class, we inherited from NS object, and that is just generic next step object, which has a lot of things like alloc and init. It also has few functions, which are Boolean functions, and they help you to determine what are you working with. The NS object has a lot of functions like this, but we're going to just check 5 of them. First 3 are instance functions, instant methods. And first one here is kind of class. That means is your object, I'm saying this is my object, kind of class and then say class fraction or any class. You just pass a class and it will check and say true or false. Now, this kind is different from member because kind will check if it's kind of a class or any of the classes that inherit from this class. And member of a class will check only the class, only the class you're passing. So if this my fraction is of type that inherits from this class, then this will say false and this will say true. So kind is more generic. It will consider all the relatives. And member is less generic. It will consider only the class you're passing. You can also check if your objects respond to different selectors. So we had set numerator, and we want to check if we actually have this thing in our object, if we can call it. And again, this function will return true or false and say if this object you're checking has this selector. We also have two class methods. And if you don't have an object, but you have a class, you can check the same. You can check if instances of this class respond to selector. So if you didn't create a fraction yet, and all you have is a class, you can still check if they can respond to different selectors. And you can also check if this class is subclass of some other class. So since we created a fraction and inherited that fraction from NS object, this whole thing will return true because fraction is actually a subclass of class NS object. And again, you can check the documentation and see there are a lot of things that are used. We're going to cover only those that we're actually going to use in the lectures. Okay, another thing which shouldn't be new to you if you were using, let's say, Java, is exception handling. And the idea is the same. If you have some line and you have some command that might raise an exception, that might raise an error, then it's a good idea to try it first, and if something goes bad, catch the exception it is throwing. So I won't explain any of this. It's exactly the same as in Java. Again, there might be a few differences, but the key idea is exactly the same. Okay, that's it for this part. Let us try to make something in Xcode, and that something will be a web browser. So here, I don't really need this, so I just close it. And I get a new project. And I create a new project, which actually will be a Cocoa project, a Cocoa application. Now, macOS is an operating system which has different layers, just like any other modern operating system. And the top layer of visual things, of all the buttons and windows and many other things that are visual and graphical, is called the Cocoa framework. And the same framework that we have on iOS, on iPhone and iPad is called Cocoa Touch. So I want to create a Cocoa application, and here we can say if it's for iOS or macOS. I want the macOS one, and create a new application, call it browser. Here you see that thing I was talking to you about, use automatic reference counting. And I say next. Save it in the same place I usually save it. Okay. So, by default, your application has one framework connected already. So you can use anything from Cocoa framework because, well, you created a Cocoa application and Cocoa framework is connected to your project. And when I say connected, it just means you have access to all those functions and all those objects, all those classes you have in Cocoa framework. But Xcode and macOS comes with a lot of frameworks. For this application, we want to create a web browser, a simple application to browse the web. The macOS has the built-in browser called Safari, and you used it on the iPhone or iPad probably. It has an engine, the actual inside mechanism that renders web pages, and it's a framework. That engine is called WebKit, and the corresponding framework is called the WebKit framework. And framework just gives you an ability to use that engine in a nice way. It has a lot of commands, a lot of things already ready for you to use. So when we created a new project right here, we have a section in the project properties called linked frameworks and libraries. All I have to do now is click on plus, and here you can see all the different frameworks we have, and I will just search for WebKit. So here I have in my macOS 10.7, this is my operating system, the WebKit framework. And I say add, and that's it. Now I just have WebKit framework in my project. It's right here. You can check all the header files and the actual framework files to see what's happening. But the good thing about frameworks is we don't really need to get that deep. You can check it, but we already have 100% of what we need for this application. So if you go to your application, it's almost the same, but here we synthesizing the new window. And the good thing about Xcode is it includes the interface builder. It includes the thing where you create your interface without writing the code at all. So if you click on this zip file, then you're going to see your application. So what we have here is the menu bar, which you can modify. This is the actual menu bar of your application. And it has all the default things, and you can change them. We're not going to touch them today. We want to click on the window and have our browser created. So this is the window of our application. And if I just save and run, I say Command R. Build succeeded because, well, we didn't have change to break anything. We have this window. This is our application. And we have this menu bar, which doesn't do much now. And we can just quit. So that's good because, well, we didn't have to write anything to create this window. What I want to do now is create a browser. So the first thing I need is the actual browsing area, the view in which I'm going to view my website. So here in the utilities sidebar, I can select different libraries. And by default, I had this Cocoa library with all the buttons and text fields and all the stuff that we use. And if I select the WebKit one, all I have is a web view. And this is exactly what I need. I just drag it on my window. And I want to make it like this. I have those rulers, which are nice because I can see this is exactly in the middle. Okay, so this is where my web page will be rendered using WebKit. And now I want to create a few buttons. So I'm just gonna do the same, drag a button here, put it somewhere, maybe here, and say this will be my if I double click, I can edit the caption. This will be my back button. So this will make my browser go one page back. This will be my forward button. So I'm just doing all those buttons that we have in a web browser. We can say reload, and probably another one here. Probably just a plus to make our text bigger. And oh, by the way, you don't have to get all the buttons from there. You can just, all the buffer things work here. If I can just copy and paste, I create a new one, or I can delete this and select something, then Command D will duplicate, so make a copy. Just create a new one and make it a minus. So another thing I need is a text field, the field where I'm going to put the address of my website I'm going to. So here we have a text field, and do the same, just drag it, make it big. That's it. So I have all the visual things I want to use. Now here's the thing that many programmers think is ridiculous, because, well, they say doing Objective-C in Xcode for Mac is not real programming, because we are sitting and writing all the code ourselves manually, and you clicking buttons and dragging stuff. But you can do it all manually. You can just go to your M file and do it all by yourself. But there's a much easier way. So I want this back button to do something on my web view. So if I hit Ctrl and click and drag, I will have this line. And I can move this line on top of different objects, or our web view object, or actually we have something here, and we're going to see it later in next lectures. But for now, I will point it to our web view. And I'm going to see this menu. This means I asked the button to do something on our web view. And what to do is right here. I will choose get back, or go back. We have this go back there because web view as an object from WebKit has this command. And we can just say this button will run this command. And I'm going to do the same with the forward. It will go forward. This reload will reload the page. As you can see, the ones that are taken already by some buttons, we have the minus here. So this will reload. This will make text larger. And this will make text smaller. And this one, it should just take string URL from. That's it. If I hit Command S to save and Command R to run, now we have this window, and if I type in the address of, let's say, our university, hit enter, we see our website. So we didn't have to worry about parsing HTML or anything like that, because we just used the WebKit. We used the engine, and this is how your website looks in Safari. It's exactly the same way. So it's not really a new browser. It just, no, actually it's a new browser, but it's using the same engine. And there are different browsers that use the same engine. It's not the engine that's most important for the browser today, but many other features that comes with the browser. So I can go different links. We can see we are doing it, but this is still crap because, well, if I resize, the window is not being resized, and this is just bad. But that thing works. I can go back. I can go forward. I can reload. And I can change the text. So that was easy, right? I'm not sure how much time I would spend doing this in maybe C++ or Java. That depends on the framework. But the good thing about Xcode and Objective-C for Mac is we have a lot of things ready. We just connect the dots basically. This is not hardcore, real super geeky programming, but this is just the second lecture. So we're going to get there. For now, I just wanted to show how easy it is to write simple and trivial tasks. We won't be doing a lot of hard, non-trivial tasks because, well, most of the products you're writing today are trivial. There are a few features, but most of the things that you want to create, someone already created. So if we wanted to render HTML in a nice way without really anything revolutionary, then why create another parser and engine if you have this and it's so easy to use? Now, if you were to create a web browser, you would probably spend some time doing something else, maybe implementing the features you have that Safari or Chrome or other browsers don't. So at this point, you might spend a lot of time thinking about those features, but you don't have to worry about making the text larger or reloading the page because, well, that's a trivial task and it's there for you. So in the next lecture, we are going to get to know more frameworks. So we're going to get to know the foundation framework, the framework that we're using 2 lectures already, and a little bit about Cocoa. So we are starting to move on to actual graphical stuff. And this is just a kind of a teaser. So you are going to start working, I hope, on your project 1. And since most of the students only have access to Mac computers in the lab, and that's not all the time in the world, those projects will be small. They won't be huge projects because the only place you can work on them is at the Mac lab. Okay. Again, if you have any questions, always write me an email. I try to answer to everybody and help with the code and find mistakes or whatnot. And see you in the next lab or the next lecture. Thank you and bye-bye.